Now we're in Chris's domain here. This is the electrical cabinet for the main drive motor. Okay, it's some temporary wires to keep us going, but that'll all get boxed up nicely for when we deliver it. And it has a control cabinet here next to it. This has the Siemens PLC equipment in, the emergency stop circuits to your requirements. Okay, Siemens power supplies, and they're just basically to supply the low voltage stuff and the I/O. Okay. Down here we've got the cabinet for near the computer desk, which has the fibre optics in it, the 16 channels of fibre optics, the encoder interface, computer interfaces, some power supplies, and the network distribution for all the I/O and the Siemens I/O in the PLC. Everything uses a network, and another Siemens power supply. Now this cabinet goes near the desk where the computer's going. Right, now this time we're running with about 860 kilograms meter squared of inertia. So we've got the two black flywheels on here. That up there's the mechanism for holding the flywheels off when you're not using them. So let's just back away and look at this side. Here we've got the belt drive, two more flywheels. That's the coupling there. Right, and then we've got the start of the telemetry system. That's the ring for the telemetry system. And the brake. We've had a delay because the mechanism here didn't fit properly, so we've had to rebuild that. It's taken a bit of a while to sort that out. So now we've got a brake on it correctly, and it'll stand up to 3,000 Newton meters torque now. So we can do a little bit more heavy braking than we did last time. Okay, so we're now going to walk back up the machine. Let's just speed it up now to 2,200. No, it's only running about 50 amps, so it'll take a while to get to 2,200. All you can hear at the moment is motor noise. The motor itself is vibrating with the main sound. What speed are we at, Chris? 300 RPM. So 300 RPM, we're beginning to hear a little bit of belt noise. That's the belt noise you can hear. So we'll go through the whole range of speeds and see what happens. We'll take it slowly to speed. What speed is it now? 400. Again, we've just got the belt noise. That's purely the belt, which is obviously synchronized with the belt noise. What speed are we at? 600 RPM. Again, we've got the mechanism at the top there, which pulls the flywheels up when they're not in use. Same at the bottom here. They're just diagonally across each other and hold the flywheels out of the way when the machine's not being used. There's a little tinkling noise appearing. I think that's the coupling mechanism. braking application. We just apply the brake for 5 seconds. Go on. Oh, it barely dropped any speed. Right, okay. Pardon? Yeah. What speed is it now? Yeah. What did you think of? Alright, okay. Pardon? RPM now. Less vibration of 1800 on the release the brake again. That's it. Okay, that's the braking application done. Right, we're coming around the other side of the machine here. We've got a flexible brake cable coming to the brake, going to a quick release fitting. It's a special release fitting that doesn't require the brakes to be bled every time it gets disconnected and connected. So that'll be fitted neatly in the bottom of the machine. That comes over to master cylinder here. That master cylinder has a bleed point in there. That goes to the brake. That flexible light cage to the brake, and then into the cabinet where the pressure gets measured. So we'll just go in and have a look inside the cabinet. This is looking at the position where the signal conditioning goes. This will have, I think it's 6 temperatures, and the telemetry system goes over on the other side over there. Okay, and then coming inside the box, we have an actuator with a commercial vehicle air chamber on the back working the brake. I've covered up the brake mechanism, you'll find out why later, and the reservoir that feeds the brake cylinder. And then behind there we've got a couple of solenoids which just turn the brake on and off, and the solenoid for the cooling system that puts the refrigeration on in the brake chamber. Okay, very simple. It's just a very simple design, and that's the complete brake actuator. Right, I brought you in the lab here to look at the telemetry system because you'll never see it like this again, hopefully. Basically, it consists of a power supply and temperature amplifier. That's this bit. Okay, so it's quite straightforward. The thermocouple plugs in here. This goes into the thermocouple amplifier. It's cold junction compensated, and that provides a digital signal. There's a digital output from that which goes down this cable into this unit here, which is the power supply and the transmitter to transmit the message, to transmit the temperature. Now the power supply runs off this coil here, and there are 8 turns in there. There's 8 turns of wire inside of a special type of wire that feeds 12 volts AC into the power supply. Okay, right, we'll move that one out of the way. Let's bring this one in here. We've got one we did earlier. Right, now this one, this is the outer ring, which you saw downstairs. Okay, now that's driven by this unit here. This unit provides 40 volts of 130 kilohertz signal to drive this coil here, which is about 25 turns. So this is buried in this material just here. Okay, now this one doesn't turn, so it's not a serious stress situation. So if we get hold of this one here, if we take this insulator off here, there's a little light bulb on the LED there. Oh, it's working already. So, right. So when this coil gets close to here, it picks up the 12 volts. Okay, now that one's going to sit there like that. Okay, now the other one, they've got to be, these have got to be isolated for each other. There's 2 channel units. So the other one is going to be the other way up. So they're going to end up like this, with the coil in the middle. So the two thermocouples are completely isolated. Let's see if it still works. There we are, still working. Okay, so that sits in there. Okay then, and then we have one on this side and one on the other side, and then the 2 cables come down from the rotating telemetry system through the head to the either side of the disc, whichever you want. Okay, so now when it's finished, you know, completed, the reason I'm videoing it now is because it'll get all sealed up, it gets covered like this. So this is probably the last time you'll see it like this. Okay then, but basically that's how the telemetry system works.